Perry Poulos.
Kavanya Gray.
Ben Vorpahl.
And our project is on heavy metals in whey protein. First, we're going to give you a little bit of background on whey protein. Whey is a byproduct of cheese and curd manufacturing. And the solid casings are the curds, and aqueous whey is left behind after the processing of this cheese. The aqueous portion is pasteurized and then dried into powder using microfiltration or ion exchange. And then there are two main types of protein supplements available. There's whey protein isolate, which is 90 to 95% protein by concentration, and whey protein concentrate, which is commonly 80% by protein. Next, I'll give you a little background on arsenic. Arsenic is a heavy metal prevalent within the Earth's crust. The element itself is usually found in minerals in addition to other elements such as oxygen, chlorine, and sulfur. In animals and plants, arsenic combines with carbon and oxygen molecules to form organic compounds. In its inorganic form, it can be used to preserve wood, and organic arsenic has industrial applications such as use in pesticides and cotton plants. And chemically, it is characterized as being a solid metalloid. Cadmium also occurs within the Earth's crust and can be found combined with other elements such as oxygen, chlorine, and sulfur. Most coal and mineral fertilizers contain some cadmium, and the element itself is mainly extracted during zinc, lead, and copper production. Due to its ability to resist corrosion, cadmium is used prevalently in batteries, pigments, metal coatings, and plastics, and chemically it's also a solid metalloid.
So, the significance of choosing cadmium and arsenic in these whey proteins. Cadmium is a dangerous metal. So, what's interesting is its absorbance in your body is directly correlated to your iron levels, or indirectly rather. So, the lower your iron levels, the higher levels of cadmium can be absorbed in your GI tract. So, what happens after absorption is this metal builds up in your liver and your kidney, causing damage to your kidney tubules. And this causes excess proteins and waste to accumulate within your blood. Cadmium also causes cancer, such as lung cancer, and it induces more aggressive cancers, such as if you have prostate cancer, having higher levels of cadmium can induce a more aggressive prostate cancer. So this is especially dangerous because many males consume these whey protein products. Another interesting fact about cadmium in these protein products is that it can mimic estrogen, which is dangerous for women. It induces mammary gland development and growth, and it positively regulates these hormone-dependent genes. So this throws kind of your body out of whack, and it induces proliferation of your endometrium of the uterus, which can be very dangerous and cause heavy bleeding. Arsenic is also important because it's also pretty toxic to the body. It likes to travel through the bloodstream, and as Perry mentioned before, it has a high affinity for sulfur, so this happens in thiol compounds such as cysteine, lipoic acid, and coenzyme A. So these are all prevalent compounds in your body that are needed for processes. Arsenic also affects the mitochondria in your cells, so it induces swelling of these mitochondria, and because of this, your cells die, not through apoptosis because there's not enough energy in the cells to induce this programmed cell death, so they die through necrosis, which is even more toxic. Arsenic also can be stored in your hair and nails due to long exposure, and this can cause cardiovascular diseases, arthrosclerosis, and it also causes many cancers such as of the skin, lung, bladder, and kidney. So the reason we chose this project is because we think through manufacturing processes is the reason that these contaminants find their way into these protein products. So the most concerning contaminants are the heavy metals, so we chose arsenic and cadmium. There's other ones such as lead and mercury. We're going to focus on arsenic and cadmium. We also chose this product because all three of us are athletes here at Ripon College, and we want to see the effects. Soccer athletes. We want to see the effects of drinking these protein products would have on us over time, and also because over 40% of our campus is are athletes, so it is very relevant to many of the students here.
So the methods that we're going to be using are based on a procedure used by Andre Kranick in 1994, where he used it to find lead concentration in the bones of yellow perch from Rush Lake. So it's a dry ashing acid digestion process. We soak crucibles with aqua regia, which is a 3-to-1 hydrochloric acid to nitric acid solution. Then we're going to dry these crucibles and place these crucibles. We're going to fill the crucibles with our protein powders and then dry them in the oven. We're going to weigh out samples of these crucibles, put them in a muffle furnace to burn off organics and to have a more pure substance. Then we are going to add deionized water and nitric acid, and we are going to boil this and reflux it. So then once the liquid is evaporated, we're going to put those crucibles back into the muffle furnace. Eventually a white ash will form, which we are going to dissolve in dilute nitric acid. And eventually we are going to use the AA spectrophotometer to analyze the arsenic and cadmium concentrations. And we're going to do this test over multiple days and a couple times a day to provide a broader range of data. Thank you.